Chapter 7, Finance. We're going to start with Chapter 7.1, Simple Interest. Simple interest formula I equal to PRT. P stands for principal, R is the interest rate, and time is T. Time usually in years. Then I, of course, is the interest. So question number 1, if you want to know how much the interest Sally earned after 1 year, then you simply take the principal, which is $1,000, times the 3.5%. Now remember, our calculator don't like 3% too much. Make sure you change that to decimal, so 0.035, and times 1 year. That's the time. So the answer is $35. Okay, one more time. Okay, so you have the principal right here is 1,000. Interest rate is the same, 6 years instead of 1. So you put 6 right here for T. So answer is 210. So what is the salary end amount, the principal and with the interest? Well, A, it means what, the ending principal, ending amount. So A equal to 1,000. That's how much money she put in, and $210 is the interest. So she'll get back $1,210. So simple interest over time. Okay, we're doing the same thing here, just another review. So this is all together now. So interest equal to PRT. P is with 3,000, R is a 5%, and T is 10 years. After 10 years, she'll get the $300 she put in plus $150, total $450. Now we can do the same thing with something. What if we only put something, we borrow a loan for only 1 month? Now remember, the principal is $500. That's fine. The rate is, we don't know. But T, this is important now. Remember, T is in terms of the year. If you only borrow a loan for 1 month, 1 month is 1/12 of a year. So instead of putting 1 here, you don't want to put 1 here. If you put T equal to 1, that means 1 year. You only borrow it for a month, so it's 1/12. T equal to 30. Now we need a little bit arch right here. So 30 equal to, if you multiply all this together, it's about 41.6666 R divided by 41.6 on both sides. R equal to 0.72, which translates to 72%. Now, compound interest. Now, compound interest, different from simple interest, is not a one-time interest. Where it's the interest is calculated based on how many times it's being compounded. Okay, so here you go. Let's take a look at a formula. Okay, so Uncle Moneybags gives nephew starving actor $2,000 to deposit into a saving account, earn a 3% interest compound monthly. That means the interest will be not calculated on one time only. It calculates every month. So monthly, compound monthly means what? 12 times a year. So the N will be 12. So the formula where N we're gonna replace with 12 because monthly means 12 times a year. Then we use the formula. So how much money would you get for after 20 years? So A equal to, the principal was the $2,000 we deposited, parentheses 1 plus, now 3%, 0.03, that's R, and right here, that's a new thing, that's 12, and to the power of parentheses 12 times 20. 12 is how many times it's compounded and per year, and T is the year, 20 years. When you punch all this in the calculator, you should get $3,641.51. Now, how much interest will nephew starving actor earn? Well, interest earned is how much you get in the end minus the original deposit amount. So the difference is $1,641.51. That's how much interest was earned. Right, here's another example. Professor Smart wants to save $20,000 for his nephew's son's child genius college education. If the account earns 5% annual interest and he participates, his son will attend college in other words, 16 years later. So how much money Professor Smart needs to deposit today? So P is missing in this case. We want $20,000 in the end, and we know the 5%. So all the players are there. Now it says annual interest. So N equal to 1. Okay, it's only compounded once a year. So when you do this, we'll do the parentheses first. 1 plus 0.05 divided by 1, and then to the 16th power. That's 2.18. Then we divide that by 2.18 on both sides. We get $9,162.23. So the principal, the amount needs to be deposited today is $9,162.23. Okay, annuity. Right. Now, annuity is a contract between a person and an insurance company that is designed to meet retirement or other long range goal. Okay, so the difference is annuity is you contribute it periodically. Okay, there's a periodic payment you have to pay. For example, you can choose to deposit, into your account every month or every half a year or every year. Okay, and for a specific amount of dollar. Okay, so here's a formula. It look complicated, okay, but as long as you do it step by step, it should be okay. The only thing that actually you probably see all of these, okay. So let's look at an example, probably easier to do. Okay, so here we go. All right. So a more conservative investment account pays 3% interest. So R is 3%, okay, 0.03. If $5 is deposit each day, that's annuity part. We're making a periodic deposit in a specific time frame. So that right there, that 5 is D right here for the that's a new this is a new symbol for our formula. Okay, and how much you earn in 10 years. So A equal to 5, 1 plus here's the interest rate divided by now 365. Okay, this well why is 365? Because if you deposit every day. Okay, so it's like number of days, number of time compounded. In other words, so since you deposit every day, so that you divide by 365 times a day. That's where the K is 365 from. T is 10. Okay, and everything else here again. This denominator is the same as this. So this is a lot of calculator work. So what I would do is try not to punch everything in one shot, okay, unless you're pretty comfortable with your technology. Otherwise, I would just do what's in the parentheses first. Do this part, 1 plus 0.03 divided by 365. And then whatever the answer is, you can write it down if you like. Take it to the power of this. Multiply this out, will be what? 3,650. All this times, and then minus 1 first, and then times 5. Whatever the amount, you can write it down somewhere. Then you divide by, figure that out first. Then you divide the two numbers. So do it. You break it down. Do it step by step. You don't have to do everything at the same time. Okay. So here it is. So how much is the interest, right? So total. So when you're done with this, okay. So how much is it? It's after 10 years you get 21,282, but that's not that's not entirely interest. That is how much you get back. But how much did you put it in? You put $5 in a day for 10 years. So $5 a day for 365 days times 10 years. So this is actual dollar amount you put in. $18,250 was the difference between how much you get back and how much you put in, and the $3,032 is the interest the bank pay you. Okay, here's another example. Mr. DJ needs $3,000 in 2 years to purchase a fancy new stereo system. How should Mr. DJ deposit amount? Okay, and then each quarter. Now, quarter means what? 4 times a year. That's where the 4 coming from. The interest rate 8%. That goes on top here. Okay, so what we need to know is how much he need to contribute every 4 times a year. So, all right, let's take a look. So the A, right, that's the final amount, $3,000. We need to find out how much you need to put in 4 times a year. Okay, so in other words, every 3 months. 1 plus, here's your R rate, 0.08. Divide by 4 because it's quarterly. And then 2 times 4 minus 1. That's the same thing as this number on top. When you're done with this, a little bit algebra, divide by 8.58, then you get, she needs to deposit $349.53 quarterly. In other words, every 3 months. All right, payout annuity. So this is an account with the principal where money withdrawal are taken on a regular basis. So it's the opposite of the annuity we just talked about. This one is you have a lump sum and they give and then slowly you're taking the money out instead of putting money in. Okay, so here it is. Here's the formula. Very similar. All the symbols you should know. Okay, so let's look at the example how this is used. Now we have the same Uncle Moneyback is able to withdraw $10,000 per month for 35 years for retirement. How much will he need needed in the account, earning 6.45% annual interest when he retire. So, all right. So, how much money you need in order to be able to get $10,000 withdrawal every month for 35 years after retirement? Okay. For 35 years for retirement. All right. So we have the $10,000. That's the money withdrawal, which is D. Okay. And we have the players right here. This is what 6.5%. Now it's 12 because it's what it says per month. All right, so there's 12 months in a year. That's why the number compounded is 12. Okay, so once you have all that, this is how much money you need to be in the account. So you can start withdrawing them $10,000 per month for 35 years. Okay, Professor Smart again. $500,000 is the same question. It's just different numbers. Okay, but this time the only we're still doing the same thing. We're doing the annual interest or payout annuity for 30 years. So just like the last question, basically everything is the same except you change the total, right? You do have the total this time. You just want to know how much you can withdraw out. Okay, the D is missing. This D right here, D is missing. Okay, so all right, D is missing. Everything else is there. So again, you need to do a little bit algebra. So once you do the calculator on the right hand side, you get 113.95 times D. You divide that number on both sides. You'll find out the money, the annuity need to put in every month is $4,387.86. Okay. Now, how does the loans work? Okay, so it's if you look the same formula, very very similar. Okay, if you think about loan is like an annuity, but you're putting it in. You pay your loan periodically, right, for a duration of time. So it's basically an application to it. Okay, it's just a different usage. So if you look, very similar than what we've done before, right? Say Raquel or Rita can afford a monthly. Now monthly, they give you the idea that this number right here n is equal to 12. The monthly car payment at $250. Now every month you pay $250. That's D right here, $250. After some research, you find out the bank that offers 5-year loan at 7%. So T equal to 5. R equals 0.07. Once you have all those numbers, okay, you have the D equal to 250, N equal to 12. You have T equal to 5. And R equals 0.07. Plug all that in the formula, you get $12,625.50. Okay. Now, what is the loan total amount, including the interest? Okay. Now we done this before. So if you look, well, how much are we paying? Well, let's see. You pay $250 a month, right? For 12 months, for 5 years. That's what he's doing. She's paying monthly, so 12 months, a year, and which is $250 each time, and then for 5 years. So that's how much, right? This is the loan total amount including interest. Now, if we take that number, we take the total. So how do you find out the interest then? So this is how much you're paying, and then if you take away how much, right, the loan is, okay. So this is how much in the end. This is the loan amount. So the difference will be the interest. Right, the difference will be the interest. Right now we have a mortgage example. If you want to purchase a house for $300,000 with a 10% down, the finance the rest of it for 6% annual interest over 30 years. Very typical. So the first thing is we need to figure out what's the mortgage, right, and what's the down payment. And we're gonna talk about this one in the next video, so we can break it down in detail.